Hello everyone. Thank you for joining us. I'm Guillermo Varela from Magnet Europe, and I'm here today with Sergio Rodriguez, John Tolosa, and Leon Broman from Morph. They have a background in architecture and are part of the computational design team at Morph's Research and Development Department in Madrid. And today they will show us many of their projects and will highlight the optimization of the Rhino plugin development process with the new Rhino 8 script editor. And they will also explain their interoperability workflow, particularly with Speckle, demonstrating Morph's commitment to improving integration and design efficiency. Remember that in the last 15 minutes of this webinar, we will have some time for Q&A, so you can ask questions in the chat, and we will check them at the end. Also, I would like to mention that the webinar is being recorded and will be available on our YouTube channel, where you can find more webinars and tutorials. I want to thank again Morph and Sergio, John, and Leon for accepting our invitation. And you can start with the presentation if you're ready.
Okay, thank you, Guillermo.
Welcome.
Yeah, before we start, I hope everyone can hear and see us clearly. Welcome to Advancing Computational Design Workflows at Morph, and special thanks to Magnet Europe for hosting this, and to Guillermo Varela for organizing. Feel free to drop any questions in the chat, as we will address them at the end. So I'm going to start presenting our office. We are Morph, a multidisciplinary team of over 165 professionals, led by architect César Frías, Miguel Pradillo, and Raquel Dueñas, founded in 2014, and this year marks our 10th anniversary. We are rooted in the AC sector, so architecture, design, and engineering services, and based in Madrid, Spain, but right now expanding our operations with a new office in Dominican Republic. So our projects spans Spain, Portugal, Central America, Caribbean, and now the Middle East. And the idea behind Morph is that we deliver innovative solutions in design, architecture, and engineering, ranging from small-scale interior spaces and feasibility studies to public buildings and master plans. And beyond architecture and engineering, we always try to emphasize technology and research, operating always within the BIM environment. As pioneers in the usage of BIM in the Spanish context, we have our own dedicated research and development team, which supports and drives innovation across all departments. Regardless of BIM, we always try to use a holistic data-driven approach, focusing on integration and optimization of processes, the unification of data to streamline design and construction, and improve coordination and cost management. The final idea is to achieve an as-built model for future facility management. And here is where our computational team appears, supporting all the design of Morph that require us. We are John Tolosa, Leon Broman, and Sergio Rodriguez, myself. And we bring an architectural background with studies in Spain, Germany, Chile, and Belgium. And our experiences span across the automotive industry, digital fabrication research, and architecture practice. At Morph, as said, research and technology are integral parts of our DNA. And we have collaborated in projects with commercial partners funded by the European Union, like Digin or BIMBOT, that you can check. And before diving into computational design, we will showcase 5 sample projects from our office so you can know us a little better. This one is BECRUX, which is a residential high-rise completed last year in the heart of Madrid, Spain. And this one exemplifies Morph's approach to residential projects, where we want to add value, aesthetic value, through continuous facade elements made, in this case, of glass fiber reinforced concrete. This another one, we are moving into project with less strict budgets. This one is called CEIBA and High Rise in Malaga, and was a competition entry in partnership with BIG and Toyoito. aimed at reshaping the skyline of Malaga with three residential high-rises. This one, on the other hand, it's a luxury residential project currently in development in Malaga. And this kind of projects with more open budgets serves for us as a playground for experimenting with shapes and investigating building techniques. And conceptually, the project aims to blend seamlessly with the natural surroundings and the landscape, which is one motto of all the designs and Morph has, like this one, which is a recent winning competition for a technology center for the Spanish Ministry of Defense. It's called CETEDEX. And the facility philosophy, again, emphasizes harmonious integration with nature. And this one is the last one I'm going to portray. As the previous project, and this one doesn't revolve around curvy shapes. So we are not using computational design only for curved shapes, as it have proven its versatility in different design approaches, regardless of the style. This one is a high-rise also in Riyadh and Saudi Arabia, and it's just a concept design for the project. So this brings up to the core of our presentation, that is our growing experience in developing and using computational design workflows tailored to real-world projects. And here with this diagram is an overview of what we have discovered. So the band diagram shows like different aspects and how those combine. The first one will be the scalability. So we'll need to be always really aware of what are the project goals and our role inside the project design. The workflows we do have to be adaptive based on our role and the phase the project is at. We will need to leverage if it needs to be fast or if it needs to handle complex logic. Another point will be automation versus customization. We can speed up tasks and make things really fast and flexible. But sometimes you will need like super fine-tune your Grasshopper script to achieve what you want, and it comes with a cost, obviously. So at the end, it's about balancing the trade-offs between quick iterations, managing complexity, and remaining adaptable to changes. And one last part, and I have to mention, is the tool integration. So whatever we do or the workflows we produce for being used to for the rest of the team, we need to streamline collaboration and alignment with our colleagues across our practice. Regardless of this matter, we are a BIM focused office, as said, so our computational design workflows must be seamlessly integrated with the BIM processes. The office, as portrayed in the diagram, usually or always use a collaborative BIM model in ArchiCAD or in Revit as foundation, where the main design is taking place. And we are, as a computational design team, we start like a parallel design loop. So we are always relying on some level of interoperability with the main BIM model. And again, it's crucial to stay mindful of the scope of our work. I'm going to explain just some steps. It's really simple, and it's like the generic overview of what a workflow will look like. And it's feeding us with, feed us, please, with some base geometry from the BIM model or data from a spreadsheet or a reference, whatever. And then we start our inner computational design loop, where we verify, validate, write scripts, and always looking to meet aesthetic, functional, or regulatory requirements. Then we need always to collaborate, so we need to provide feedback in some way to the rest of the design team. And if needed, we sometimes will need to refine our model and incorporate further information and further development to achieve construction, for example, requirements. And the last part will be the exchange. So we have to deliver detailed models to clients, partners, or manufacturers. Typically, we use the IC format. It's our preferred way to share, and is an industry standard. So the idea is to ensure minimal friction with the native BIM models. As mentioned earlier, the ability to make quick and strategic decisions is crucial for a computational designer, and it's something that develops with experience. At Morph, the design process often begins in a traditional manner, and this project is an example of this, like with a sketch, which is something that challenges us to develop effective solution based on very little information. So in this kind of conceptual phases, it's essential to keep the Grasshopper script light and flexible as the design evolves daily. And often we are racing against designers who rely on manual approaches, so we need to be quick. We are now jumping to one of the two workflow categories we have like conceptualized. And this one we have called the basic. It doesn't mean it's less than the other one that John is going to present. It's just that it is a straightforward workflow that relies on various data exchange formats, and it's valued for its simplicity. So when enriched geometry with metadata or complex integrations is not required, this one is an ideal option. I'm going to also explain like our tools here. The main collaborative model is usually an ArchiCAD teamwork file. Sometimes we work in Revit, but we mainly work in ArchiCAD. And our computational design loop and design is taking place in Rhino 7 or Rhino 8 plus Grasshopper. Right now we are more completely into Rhino 8. And yeah, the basic steps of this workflow would be to import the BIM model geometry as a reference to Rhino, compute and develop our solution with help of Grasshopper, and then export the design in the desired formats. And it's going to depend if it's going to feed back into the BIM model, or for example, given to the visualization team and imported to 3D Max or whatever. So now I'm going to show two examples of projects that are in line with this basic workflow. This one is BOSQUE ATOCHA, a residential building built in 2014. And it's a good example of a typical computational design project where it's designed in Grasshopper and the rendering elements are executed in glass fiber reinforced concrete. And in this case, we use north-based geometry to ensure continuous surface connections and detailing. But in this case, this is a build-to-rent project. So maintaining simplicity is crucial to ensure feasibility and staying within a budget. So the objective was to achieve an appearance of complexity with fewest possible elements, optimizing both design and cost efficiency. This is a picture when it was being built, but it's finished right now. And if you are in Madrid and have interest in facades, it's worth checking out. It's just 18 meters from the main train station, ATOCHA. And moving on, the other one, this one is DOHA Core Complex, and we are moving to something completely different with this recent competition entry. This one is located in Qatar. It's a justice core complex in Doha, and it's over 15,000 square meters. So it's a small jump in scale compared with the first project. And in this case, and the nature of these competitions demands that design the ideas evolve quickly, requiring the team to adapt daily while working under tight deadlines. Due to these time constraints, scripts are often not fully optimized, as you can see in the background. We usually are not, it's not a concern to have everything perfect and data structures perfect and the script perfectly optimized. But it's more about if you have to copy paste things and tweak something there, feel free to do it because we don't have time. We need to explore different design alternatives. And to accelerate this process, in this particular case, we used tools like Weaverbird and Pufferfish, which are plugins for Grasshopper, and are intended for mesh-based geometry modeling, which offer faster results compared to NURBS when the scale of the project is in this range. So in this context, for us, smooth surface transitions were not a priority. So our focus was on achieving a high level of detail, so visual impact in renderings, while preserving overall shape flexibility. And for most competitions, the visual impact and the renderings are the final output of our work, and we are not the end of the line. So we have a dedicated visualization department at Morph, and we have to provide them or an external rendering company with timely updates through the processes. And now I'm going to hand it over to John, who will continue with the presentation with the expanded workflows.
Okay, thank you, Sergio. I'm going to introduce you the enhanced workflows, the second workflow that we're explaining today, second and last. Between the first and the second project that Sergio has shown, 10 years passed. And of course, computational design has gained a relevant role in our office. Back then, in the very beginning, Morph had just one single Grasshopper user, but right now we are a full computational design team. More and more projects require our resources, and we are already involved in the whole development process of them. We are not only involved in the early stages, design stages anymore. We are like the competition entry that Sergio just explained. And the geometry is important, but also other things like because in the later phases of the project where the integration with the general BIM workflow of the studio is extremely relevant. As Morph itself, the projects where we are working are getting bigger and bigger, and the work has become more collaborative, leading to some growing pains. There are some issues with organization and quality control, and efficient project tracking is crucial as we jump in and out of various projects. This diagram shows an abstraction of these enhanced workflows, which have a data-driven approach and are more streamlined than the basic one that Sergio showed. But we adapt all because for every case, for each project, the workflow is adapted for the project needs. But what all of them have in common is that metadata plays a huge role ensuring an aligned workflow with the BIM methodology. We're always looking for new ways to speed up tasks and improve our quality of life. We are all constantly checking the plugins and tools that are on the market. But we are also even developing our own custom toolset that we call Morph MEDUSA, that Leon will explain later. But I would like to talk about it a little bit because among this whole toolset that we've created, we have some tools that connect us directly from Grasshopper to the Morph Cloud. This Morph Cloud is something that we've called, we named as Morph Cloud, but it's just the platform that Morph uses based on Google Workspace and AppSheet, where all the administration and management solutions are and all the databases are stored. So it is very important in all these spaces to connect to the Morph cloud to ensure an overall proper coordination with the rest of the teams. Apart from that, we also keep an eye on very close to all of these emerging collaborative tools for direct interoperability, such as ArchiCAD Left Connector or Rhino inside Revit. But yeah, mainly we use ArchiCAD Left Connector. We have more experience with that because in the studio we tend to use ArchiCAD more than Revit, but we still have some experience with it. But yeah, we prefer to still keep our workflow more encapsulated to the McNeil environment, where we feel more confident and don't interfere with the rest of the teams. This leads us to another big issue that Sergio already introduced, that it is interoperability. Because just as the AEC sector itself, Morph is a multidisciplinary firm, and each distinct discipline has its own software. The engineers have their own ones, and we have our own. Proprietary formats limit data flow between platforms, and it is very important that all the softwares used by the rest of the teams in our studio can be the data that we inject in the geometries that we produce. IFC has, sorry, can you follow the presentation, or are we still on the, yes?
No, it's okay. It's okay.
Okay. Sorry. Yeah, I was talking about the metadata and the interoperability, and talking about so the IFC has proven to be a powerful format for exchange files because, as Sergio said already, it's a non-proprietary format. Yeah, for this metadata injection, we commonly use VisualArc. VisualArc is a plugin for Rhino and Grasshopper developed by SonyCAD, which introduces BIM methodology to Rhino and Grasshopper. Apart from VisualArc, there are many other different plugins that we've already tried that allow to work with metadata in Grasshopper and Rhino, like MetaHopper, Launchbox. But we tend to use VisualArc because we can generate with it IFC files to export to the rest of the teams. Enough theory by now. Let's move on to show 3 different projects that showcase this kind of workflow. We will start with Sunset Sailors, this high-rise project in Benidorm, Costa Blanca, Spain. To start off, I would like to tell a few fun facts about Benidorm, that here in Spain, it is nicknamed as the Spanish New York because it has a lot of skyscrapers, and so that you know, it's the 3rd city in Europe in concentration of skyscrapers. And why so many skyscrapers in a city that has just 70,000 inhabitants? Because in summer, it multiplies by 7 their population, reaching to 500,000 inhabitants over there. Yeah, so this is going to be one of those skyscrapers, or 2. And in this project, the developer just hired Morph for the exterior design. The client had already designed the most cost-effective floor plans, and starting from here, Morph had to design an appealing facade that will comply with their requirements and urban planning regulations. The creative team came up with the idea of these curvy shapes that try to mimic the sails of a boat and reached to us to make everything work. As computational designers, we're in the middle of these 3 compromises: the creative design, the fixed floor plans, and the urban planning regulations. And yeah, so collaboration was a key for the project success. We creating some kind of a traffic light system to visually show the creative team how their design solutions were affecting urban planning compliance. And apart from that, we developed a small script that automatically updated a spreadsheet with the surface data so that developers could constantly check if we were fitting to their requirements. This script finally developed into a tool inside our Morph toolkit, the MEDUSA. So apart from creating a script that generated all these towers parametrically, we had to generate solutions that integrate and fit all the teams and requirements involved in this project. So the creatives had their fancy, visually appealing tool to work with it, and the developers had their engineer-friendly data sheets. Right now, it's under construction. This is a picture that John took this summer in vacations because he was over there in Bengal. And you can see how it grows if you go there by now. We're moving on to another building which is under construction, but this one is in Capcana, Dominican Republic. It's a residential complex that consists of 3 U-shaped buildings that embrace amenities and a golf course. This project is completely the contrary to the previous one in terms of constraints, because here there were no such many constraints, and Morph had much more freedom to develop it. From the very beginning of the design phase, the creative team realized that they would need our resources because they wanted a free-form design. So they involved us in the project from a very initial stage. This gave us the opportunity to influence in some relevant design decisions from the very beginning and eased our work later on. These intertwined parapets that you can see over there are executed in glass fiber reinforced concrete. As you may know, probably know, that these parapets are created with molds, and each different kind of mold impacts directly in the budget. So rationalizing them was key to make all these free-form designs constructible, maintaining cost efficiency. As in the early stages of the project, we helped designing the outline of the buildings, taking this into consideration. Element discretization and optimization was much easier later when they came to the phase of having to build it. To ensure precision and collaboration with the rest of the disciplines in the execution phases, we produced an IFC file with all the pieces to insert it directly in the collaborative BIM model and make them available to all the teams. This file contained each mold codified, identified, and enriched with relevant metadata that the rest of the teams could use. The outcome resulted in a great case of success of free-form design combined with element discretization and interdepartmental collaboration. As you can see, it's under construction. I wish I could show you the mounts already placed over there, but they are not there yet. I expect them to come over soon. We're moving on now to the last project that I'm showing. It's this one, TRAPICHE. It's a residential project in Costa del Sol in Spain, and it is currently under development. It seems to be a very similar project to the previous one, but it is definitely not. This project consists of 35 blocks integrated in a steep landscape, and the most outstanding feature of its design are these glass reinforced concrete parapets again with organic and sinuous shapes. Unlike in Wave Garden, the free form of the parapets were already designed when they reached to us. We were involved in a late stage of the project in the execution phase. So apart from that, they wanted us to make these outstanding renders constructible as something similar to what we did in Wave Garden. But how could we rationalize an already designed form I adapted to the 35 building blocks, and of course, with they were running out of time. They wanted to make it quick. Luckily, most of the modes were just the finishings of shading elements, so we had a little bit of flexibility to change their baseline or outline. We had 35 different building blocks to fit, so divide and conquer. We condensed all the cases in just 3 different singular cases that were repeating all over the project. For each of these singular cases, we created a script that, relying on Kangaroo was automatically rationalizing all these outlines and baselines. The script was discretizing automatically the section lengths and the angles between them, and this way a limited amount of modes were generated, preserving the fancy organic freeforms but making the project cost efficient and buildable. Then we applied this procedure to the rest of the building blocks. Apart from that, to help manufacturers to build this project, we developed another script for automatic negative mode generator that you can see over there on the left. But if you want to learn more about fancy tools that we've developed in our department, let me introduce you to Leon, who will show you many more.
Thank you, John. So tool development is part of our work at Morph. In the last 10 years, our office grows, so our project grow also, and in-house solutions and tools became more and more important in our office. So when we're talking about tool development, it's important to understand that we are developing these tools for different user groups. So for example, of course, we are writing them in first case, mostly for us as internal tools for fixing workflows, making things faster, and so forth on, but also for other departments. So writing tools for our interior design team or for the design team, so forth on. So in the end, for all the Rhino users in our office. And the last group, which is also an important group, is of course our clients. This can be, for example, some kitchen designer software or some automated measuring tools to help to understand the project, also to sell it to their clients. And now I would like to focus on one recent development, and that's our revamp of our Rhino toolkit, MEDUSA, we call it. What's MEDUSA? It's an internal project at Morph for streamline basic tasks in the McNeil environment, so Rhino and Grasshopper. The project started in 2021 and includes more or less 20 plus commands and also 25 user objects, snippets, and components. And yeah, it makes our life easier when we're working with Rhino. So for example, what's a really important part is to enhance interoperability, as it was already said in the presentation. So often, like how we are getting data from other projects to Rhino, or also out, so importing and exporting. For an actual case is in ArchiCAD. Of course, you can export in ArchiCAD your files as 3DM files, but these files are in big projects basically unusable. They are using multi-layer nested blocks, which leading to really long loading times, for example, and strong performance issues. You can see how in the video how laggy it is, for example. So we are automated, and also the layer structure when you get the project, or the layer structure of ArchiCAD is not there yet, and it's difficult to invest in the project and finding the right elements. So our solution was to automate the the import of these 3M files, so the exploding of blocks, reading data inside these objects, and rebuilding the layer structure. And in the end, also, for example, baking all the meshes in the depictive groups, so to enhance the performance. So in the end, we have with these tools big time savings, and we automatized our post-processing process. Another thing which is really important for us is the project management and quality control in our computational design team. And as John said, we are working with Google Workspaces and AppSheet. So it's an important thing to connect to the Google API. So when we want to manage projects internally, open-close projects, we're doing it directly in Rhino. We do not have to open another website or opening another solution. We're doing everything in Rhino. For example, it's checking when we are starting a project. It's downloading already the Morph template file in Grasshopper. It's checking if the file is already saved correctly. And when we are closing a project in the end, also it's helped us easier to archiving these kind of projects, making screenshots and so forth on. So we can easily, after 1 year, we can easily go back and see what we did. And another thing which is important, of course, we can add performance indicators, so metrics for our team, HR and management, so we can see which project took us a long time, so and where we have to improve, and also where we can discuss issues also better with management, and because we have the data in front of us. To recent developments, we overworked these Toolkit lately. We had some challenges with former Toolkit. So, for example, we had a really scattered code base before. As I said, the project is from 2021. Some things were programmed with the toolbar editor. We had some macros there, some Rhino scripts, some Rhino player files, and also the separate user objects. And we had an installer to install it on different computers in the office. But once it was installed, we could never change it or update it after the installation. So in the result, we had a neglected code base. We had the project, but it stayed in this shape. And when we had changes, it were just locally on one of us computational designers' computers. So we said we had to change something. So in this year's spring sprint, we try to improve our situation. It's classically the time where we are cleaning a little bit our office structures, and we computer designers also cleaning our codes, of course. So we took our time and we said, okay, we want to improve it. Our team is getting bigger and bigger, and we need to collaborate more with these kind of tools. So what were our goals in that spring sprint is unify and simplify the code base while establishing a decent development workflow to develop these kind of new tools. We wanted to add version control and improve team organization, so connected to our Git workflow, and improve also team organization. Another point which was really important for that is also the ease of entry, maintenance, and use. So the time when we have a new colleague, teaching the tool takes time. And we didn't want, for example, to write a full net plugin where you basically have to start to explain maybe someone who comes basically fresh from architecture university about solid principles or programming pattern, which can be sometimes a little bit tough. So we wanted to simplify it. And of course, the thing we wrote already in the past, maybe it's not beautiful code somewhere, but we didn't want to rewrite everything from the beginning, so we wanted to keep it. And also, of course, we wanted to keep it designer friendly, so allowing it that designers, us, and also your colleagues can program with Python, C# or just visually in Grasshopper. Because for us in our office, it's important that we know that every computational designer or designer has a different focus, interest, and knowledge. And we also want to keep it like this. So we don't want to equalize that everyone knows the same. We want to have specialists in the company, and we want to have the one guy who is focusing on Python, the other one in more in the net environment. And yeah, we want to keep it like that way. So we were thinking about how we can do it. In the end, we decided to use the new Rhino 8 script editor for that. The idea came at the IAC Barcelona conference this year, organized by McNeil, Core Studio, and BIC. And they had an awesome workshop about the new script editor. And yeah. So about the script editor, most people know with the new version, it's like Python script, C# script, Rhino script, they are now using all the same editor, not 3 different ones, how it was in the past. And also, of course, that it's much easier now, or it's now possible to have Python 3 libraries, which is really awesome. We are really excited for that feature. And also like adding like C# and nuggets is also possible. But what people maybe do not know, and what's not so much published, that you can easily build plugins and publish packages with it. So you can easily stay in Rhino in ScriptEditor. You can create a new project, and you can with one button click you can add your Grasshopper components and build a package in the next second. And in the end, for us, it was really easy to integrate it inside our Git folder and a Git structure. So we have one MEDUSA folder with all the Grasshopper script user objects and yeah, the MEDUSA project file, which is created by the script editor. Then we added also some C# console apps for debugging, third-party libraries, and also like UI templates for Rhino, and also our Google API Bridge library we added, and working just normally how you would work in Git. Git version control concept has been around in IT since 20 years. So what I'm just explaining just a little bit what it is. So every one of us designers can create a new feature for the plugin, and everyone's creating a branch or everyone working on it. And then we decided, okay, we put in everything together, and Git makes it possible to create one version with all the changes. So it's really easy to work asynchronously on it. So, and once we have the version, which is good internally, it's easy for us just with one button click, we can export the package. Now we wrote a script, which we have one library folder in our Morph clouds, which is our package manager shows, and the script basically just checks if the file has the right naming and copy it there. And then and all the Rhino and all the Office, the Rhino installations have this folder as a package manager source in the settings in Rhino. So it can be found through the standard package manager, and it can be installed kind of easily. We created an installation script. You just drag and drop it in Rhino, and it installs for you the package for you alone. And once it's installed, that's the nice thing. Every time we are pushing an update in Rhino in the whole Office, the new version is also installed. So it's really comfortable for us to deploy the software to our colleagues. And of course to us, also to us. So we're really happy with the workflow and how it went out. And we are also really supporting the ongoing on that on McNeil to where is it going? We're really happy about it. So now about another thing, which is also important and like the last part of the presentation. Another point is collaboration in large scale. So as we are focusing more and more to improve collaboration between us in our computational design team for large projects. So, for example, we are working right now on a stadium renovation in Malaga in Spain for the 2030 World Cup organized by FIFA. To understand the dimensions, so the programmatic space is about 40,000 square meters with over 40,000 seats, and just alone the facade is 750 meters long. So this is a different beast, this project. And of course, the project is so big that at some time the whole computational design team worked on this team. But you have to understand that there are different areas where we're working on, and also the output in these kind of big projects are different. So, for example, one is we need detailed close-up for interior renderings, for example, or geometry for videos, or data from analyzed seat positions, which needs to be going out as spreadsheet data. And of course, we have still our collaborative bin file, and this guy is a big Revit project. Is also need to be fed with this data. And this is where we're coming now to Speckle, as many of you maybe already know, is the open source data sharing platform. And it helps to connect different kind of programs together. In the end, it's a platform where you can push your data on from different software. So from Grasshopper, Rhino, or Revit, or whatever software, you can push it to the cloud, and then you can import it or pull it again from it to different projects. So, and for example, for our project here, we work with different kind of Grasshopper files. We split the project in different kind of elements. So one the facade, the other one the roof, and the other one the railings and the detailing. And to the same time, we supported the design team for creating a video in Blender, and also supporting the architects with the actualized version for their plans in Revit. And now, for example, what we created with that is this video in the background. And here I just want to come to an end from the presentation. So I want to give like a little bit an outcome where we are seeing where computational design is going for us, for our office at Morph. So what we're seeing, like we have more and more collaborative workflows and always more options to connect software. So we have a more advanced interoperability between these kind of solutions. And also where we're seeing it, because our team is getting bigger, we have more time, and being we can program more custom tailored computational tools to support us, but also more and more to support our design teams, which may be working with Rhino, but not in particular with Grasshopper. Some of them now it's Grasshopper, but yeah. So for them, it makes sense that we are writing the tools for them. And another thing is these tools and all these workflows, besides being more cost effective, of course, it gives us much more room for design to explore. So this is an office which takes face and is really proud of the design and put the focus on it. And we are seeing that we have more time, or we want to have more time for exploring different kind of design possibilities. So we want to strengthen more and more the design efficiency at the office. And this is where we are seeing where it's going. I think.
No, thank you, Leon. And thank you to everyone. And we are leaving our contact in the screen. And I hope you have enjoyed. And we are open to your questions in the chat if you have any, and we will be pleased to answer.
Yeah, thank you so much. It has been great to see all the projects and all the tools that you use in your workflow, and how you combine them, and how you collaborate with your team with all these tools. I think it's really impressive, and I think it's also interesting for all of us that work in architecture to see how you use so many different options in your projects. I see that some people is writing in the chat. Let me check if I can follow it. Yeah, Gerald Mandef is saying that the Speckle integration is impressive. Um, I'm trying to read, but it's going fast now. Okay. They're also saying very cool projects and workflows. Thank you for the insights.
Yeah.
Yeah.
Thank you very much. But feel free, if you have questions to it, just feel free to contact us and give an email address here. When you send it to this, it will be sent to us and we can read it and hopefully answer.
Yes, as in the beginning, the presentation is being recorded, and I will try to upload it probably tomorrow in the morning, and I will send an email to everyone. So if you have any questions, you can just answer the email and I can send it to you, or you can contact them directly. Tiago Santos, for example, is asking how in depth you are with design for fabrication and how you manage with client and contractors.
Yeah. Okay. Okay. This is a complex question because as we are evolving as a computation as a team, we always have someone in between in the studio that is the head or the manager of the project. So there is a team that is developing the project, focusing in the BIM environment. So we are not in direct contact with the client most of the time. We sometimes are in the meetings attending, but we are not in direct contact with the client or the contractors. We are when it's needed. Yeah.
Yeah,
So
there is yeah, sorry, go ahead.
Yeah, it depends a little bit also on the project, but for example, getting more contact to the manufacturers is an important thing, and we are also hoping to get more connections to that point.
I'm going to pick the one from Gustavo Pardo. So
Yeah,
what's the contractor reaction with the complex geometry? Is the cost over the moon? As said, we don't see the first reaction of the clients or the contractors, but yeah, it's a tough process, and we need to deliver like credible documentation apart from the renderings. Yeah, at the end is just the first step with the renderings to make everyone fall in love with the design, and then the numbers come up. How do you think the AI will be integrated in the future projects?
That's a good question.
Yeah.
But maybe because you're working on it right now.
Yeah. I mean, right now we are working with Flux One model in Comfy UI. So we are generating our images in-house to not rely on any cloud service. And for now, we are having relative success in early stages of design. So before start parameterizing an option, maybe it's worth it to explore like a spectrum of design, so we don't have to modify our script that takes time to write because the design was not profoundly explored in the beginning. So yeah, we are having success like implementing control nets with the image generation based on rough sketches, 3D sketches and renderings.
Thanks. Yeah, I see another one from Bu Nguyen that asks if these complex projects have only one Grasshopper file each, or you can manage multiple Grasshopper files for a project.
Well, in some of them, some of the projects are too complex to handle with just one script, but most of them are condensed in just one. If the script is getting too complex and it starts to slow a little bit down, it's recommended to split it a little bit and maybe have more than one Grasshopper file.
it also depends a little bit the phase on it. So when we are working on the design, often things are kind of rough, and we have maybe multiple versions of the same project. But in the end, when we're going about the project and the fabrication elements, and we have to be more detailed, it's mostly one file. And as I said, then mostly also the file is kind of optimized. So the part of the design is still there, so you can wiggle a little bit around in the design, but change the number slightly a little bit more to the right, and you know how it is. So
yeah, but for integrating different grasshopper files, we are using baked geometry, like using Speckle, or like merging the modeling somewhere else, because including like dependencies inside between grasshopper scripts, like you can make in theory, you can make one grasshopper script depend on many others, and start like a nested nightmare.
yeah.
So that's something we are not doing. We will try to keep as our workflow everything condensed and enclosed into one solution that we can easily track, and it's not getting lost or unmanageable.
I would like to answer the question about the Kangaroo application of optimizing the facade modules. Did you use Kangaroo to assess all unique modules and reduce them to a target number to ease of production? Yeah. So in the end, we are still right now figuring the best way out and these kind of scripts. For example, we have different versions of these tools. We are trying to automate more and more. So of course, in the beginning, it was a lot of fiddling around, like changing the amount of elements. But in this particular project, we figured out a number which was working for us really well, and then we continued with this process. But it's already in a plan that we are focusing a little bit more in automatizing it, and yeah, maybe connecting it a little bit more to machine learning solution. But for that, the project has to come all the time. Yeah, so when there's a similar project, we will start basically what we had before, and adapting that script and optimizing that. But like, we are not creating tools without the need of it, for example.
And the question from Adapena: do you use OpenGIM, IFC, OpenCL, Python to automate tasks, inspect, modify IFC files, and to create those for the animations? Well, we have some experience with XBeam, which is a package for C#. So we have some experience with like analyzing and editing IFC with XBeam. And right now we are jumping into the possibilities that Speckle give us with their SDKs. And because at the end is structured data like the IFC, but it's easy to share, and they provide us with a like environment to do so. And regarding this 4D animation, it's geometry imported in Blender, and a lot of hours of work.
Yeah, I'm answering the next one from Tyler that, well, I will ask here. He's asking if with Rhino you can get some detailed files for wooden furniture and CNC manufacturing. And I think it's possible, and you can find some webinars about furniture fabrication with Rhino and Grasshopper and digital fabrication. So I think if you check tomorrow the recording of this webinar, you will find also some other webinars about furniture with Rhino and Grasshopper. But yeah, I think it's completely possible, and you have seen the detail in the project. They have shown that they have all the structure, all the facades, elements, all the 3D information in the same model. And the next one from Serkan.
Okay, the gap between The big model and its actual shape at the real application. Or it's geometric model.
I guess you mean like continuous surfaces and then the need to make like big pieces. So at the end, it's just we need to build them and within a budget. And yeah, in theory, you could make a big continuous shape. Well, if thermal dilation wasn't a thing, but yeah, it's just thinking differently. At the beginning, you are thinking everything is possible, and grasshopper geometry and nerves can do whatever you want, and then you start thinking about how it is built. And there is, yeah, that's a good question because it leads us to where is the point to start thinking like an engineer that will need to build this instead of just create a building or a 3D model for reference. Yeah.
Yeah, thanks for the answer. Yeah, I was thinking if most of the facade panels are standardized at the end, or are they completely different from one to the other? I mean, in the facade, in the facade balconies that you have.
Sorry, what you guys not using Unreal Engine? We are using Unreal Engine, but in different cases. So we have Javier Torres, another computer designer, one of us. He's working with Unreal, the Unreal Engine. For example, having interactive models with clients. But of course, when you have a video, for example. Blender is also a really nice tool to create animations and
and it's open source and it's free, and sadly Unreal Engine is no longer like this.
Yeah, so has connected with some cost.
Yeah, and there's another one from Tiago, and also Danny is asking to ask these questions. Is how are you managing the metadata of these objects to meet the IFC specifications and target industry standards when generating the information in Rhino?
I mean, industry standards. I mean, in the end, about that have the IFC file is readable. In the end, like Visual Arc is kind of got the plugin for Rhino to give us IFC data, which can be read in a lot of software. But I mean, the reality is you have to figure it out a little bit how you're modifying the metadata for IFC files, because every file or every program will read the IFC file different. Like ArchiCAD will read it different than Revit or CEIBA or another engineering software. So sometimes this can be really frustrating to get the right IFC file. And so maybe we have for two different programs, two different IFC files, which basically saying the same. And I mean, my tip is just export an IFC file in the program which you're using and check with an IFC, OpenIFC reader, the data structure, and then try to replicate it.
Our approach is like not trying to replicate the any standard, but encapsulating again like our relevant information for our inner usage in the studio, because the final IFC is going to came out of the BIM collaborative model. So we are creating a property set inside the IFC scheme that makes sense for us, and to have the parameters we want to share located in one place.
Yeah, I was sharing your webpage because Madan was asking about the company. You can check all the information there. I think Tiago's answering your answer. Yeah, okay, thank you. So I think that's all the questions, and as we are running out of time, I think it's okay. So thank you so much again for the presentation, for all the work preparing the material to show us. It has been really great. And thank you for the questions to all of you have have attended the webinar. That's all. Have a nice day. Have a nice afternoon. I don't know if
Thank
you
you
want
so
to add
much
anything.
for all your time, for all the participants.
Bye.
You're
Bye.
welcome. Bye bye.
Yes.
Ciao.
Adios.